Hi, this is Professor V.K. Patil. I welcome you to the video classes on digital electronics fundamentals. This is the module 5 of your syllabus. In this module, we are going to discuss about signals, the types. So we have three types of signals: analog signals, discrete time signals, and digital signals. Next to that, we are going to discuss the different number systems. The different number systems are a decimal number system, octal number system, hexadecimal number system, and binary system. In these all number systems, we are going to see how these all different types of numbers are added, subtracted, right? So next to that, we are going to discuss fundamentals of a digital electronics. So in that fundamental, we are going to discuss about the Boolean algebra, the rules of Boolean algebra. Then we are going to discuss about the very minute or the basic digital electronic circuits called as gates. In that, we are going to discuss the two types of the gates. One is basic gates and another is universal gates. Next to that, we are going to discuss the simple digital circuits, adder, in adder. Again, we have half adder, full adder. We will see in detail later on. Then we are going to discuss about the multiplexer, flip-flops, shift registers, and counters. This is all about the syllabus. Let us start with the first bit of the module, that is nothing but a signal. What do you mean by a signal? What do you mean by a signal? Basically, signal, it must be a physical quantity. This is very, very important. It must be a physical quantity. Also, it should carry or convey some kind of information. Then only we can say it is the signal, right? What is the definition of a signal? The signal is a physical quantity which conveys some kind of information. That is nothing but a signal. The different examples of a signal, I can say the temperature of the room, the speed of a fan, the voice signal of one particular person, video which is captured by some person, the text message. This is also a signal, right? So these are the examples of a signal. Signal, it can be a two-dimensional, three-dimensional, or multi-dimensional, right? The two-dimensional signal means what? We have one independent parameter and one dependent parameter. I can plot it by using XY plane. If it is the three-dimensional signal, we need to use XYZ plane, right? And if it is the multi-dimensional, I need to use the multi-dimensionals to represent the signal. Basically, the signal is classified into the three types. So these types are analog signal, next one is the discrete time signal, and last one is digital signal. Analog signal, it is also known as continuous time signal. Analog signal is also known as continuous time signal. Let us see one by one what is this analog signal, discrete time signal, and digital signal. The analog signal or continuous time signal is the signal which has the amplitude at all values of a time, right? So it is the two-dimensional signal, let us assume. So on the vertical axis, we are going to plot the amplitude. Horizontal axis, let us say we are going to consider the time. This is the time dependent function. Let us assume that we are plotting the time dependent function, right? So the parameter what I have considered on a horizontal axis is known as independent parameter. The parameter what I have assumed on vertical axis is the dependent parameter. It means that amplitude, it depends upon the time, right? So time, it is not dependent on amplitude. Hence amplitude is the dependent parameter and time is independent parameter. Always we need to plot the dependent parameter with respect to the independent parameter. In analog signals, the amplitude of a function, it is present for the all values of a time. In other words, I can say the dependent parameter is available for all values of a independent parameter. Such signals are known as analog signals or continuous time signal. So time is continuous here for the all values of the time. the amplitude or the information is available. Such signals are known as analog signals. And majority of the signals what we see nearby to us, they are analog. The next type of the signal is discrete time signal. In discrete time signal, signals, the amplitude is available for the discrete values of time only. So here amplitude is available for the discrete values of time. What it means? The dependent parameter, it is available for the different distinct values of a time. For example, at t is equal to 0, we have some value. At t is equal to t1, we have some another value. At t is equal to t2, we have one more value. t3, we have one more value. So amplitudes or the information is present at these values only. So in between these two values, there is the time gap where we do not have any information. Such signals are known as discrete time signals. Any continuous time signal or the analog signal, it can be converted into the discrete time signal simply by performing the sampling. Right? The type of signal is digital signal. In digital signal, we have a finite amplitude levels. What do you mean by finite amplitude values? So let us assume the digital signal which has only two amplitude levels. So at certain time 0 to let us say t1, it has one amplitude level. This is let us say level 1. So it has some value. In between t1 to t2, we have another level. Let us say this is level 2. Digital systems, it has finite numbers of amplitude levels. The signal which has a finite number of amplitude levels is known as digital system, and usually the digital signals, they have only two amplitude levels, either amplitude high or low. In some times we use the positive voltage as the logic high, zero voltage as logic low. In some applications we use positive voltage as logic high, negative voltage as logic 0. These are nothing but the different types of signals: analog signal, discrete time signal, digital signals. Right? Next to this, we are going to discuss the number system. What is this number system? What is the number system? The number system is a set of values used to represent the quantity. Right? What is the number system? The number system, it has the set of values which are used to represent the quantity. We have different types of number systems. So these two types of the number system are positional number system and non-positional number system. Positional number system, these are also known as weighted number system, where these are unweighted number system. So in this model, we are going to put more concentration on positional number system, that is weighted number system. In non-positional number system or in unweighted number system, what we do is we do compare one-to-one objects and we will do the counting. Whereas in positional or the weighted number system, each and every digit of a number system, it has its positional value as well as face value. Positional value is also known as place value. We will see later what is this face value and place value. So the different positional number systems, what we are going to discuss are The different positional number system what we are going to discuss are: first one is decimal number system, second one is binary number system, third one is octal, and last one is hexadecimal number system. So these are the positional number system which we are going to discuss in our classes. Thank you. In next class we will see more about this positional number system.